All right. So this video is going to talk about some of the simple stuff about the atom. Long ago, the Greeks were kind of wondering about the nature of things. And so, for example, they knew if you could take a nugget of gold and cut it in half, you had two nuggets of gold. They both had the same properties. So there's two possibilities. One is you can keep cutting it forever and you get smaller and smaller pieces forever. Or there is a certain small piece of gold which, if you cut it in half, no longer would be gold, or maybe it's not even possible to cut in half. And they call that particle the atom, and so the person who thought up that idea gets some of the credit. However, the Greeks were not big on actually doing experiments. First of all, they couldn't. They had no equipment, they had no scientific background, and so they had to sit around and just think about how things were. And so much later, people started breaking compounds down into their elements through, first of all, alchemy, which then became chemistry. And so when we talk about breaking a substance down into its atoms or its elements, which are made up of many atoms, then we mean by chemical means. So we all know now what the atoms looks like. So Thomson was the first to kind of discover that maybe there was some sort of particle in the atom that had an electrical charge. And so, if you look at the old TVs, which are a great big old vacuum tube, there's an electromagnet that deflects an electron beam, and so magnets will deflect charged particles, and so that's how the picture is created, because it would deflect the beam back and forth, scanning and making an image, because the electron striking the screen would make it glow. And with black and white, it was either glowing or not glowing, depending on how intense the beam was. And so he called these cathode rays, and this is called a cathode ray tube. And so we now call them electrons. Okay, so that got them to thinking, well, you know, matter doesn't seem to be charged, and so if there's some negative particles, there must be some positive particles. And those positive particles we now realize are called protons. And in an atom, it turns out for it to be electrically neutral, the number of electrons must equal the number of protons, because the charge of one electron is exactly the same as the charge of one proton, except the electron has a charge of minus, and the proton has a charge of plus. And so we can say what this is on a macroscopic scale, like, you know, how much electrical current in amps would be how many electrons. But at our level, we're just going to count them as integers. One electron has a -1 charge, and so a proton will have a +1 charge. Okay, so then Rutherford used some radioactive material to create a beam of alpha particles. And so I'm going to, and it contained 2 protons, and now we know 2 neutrons. This is very heavy material, and so the idea was he was going to shoot it through a beam, a real thin sheet of gold atoms. Now gold is really malleable. You can make extremely thin layers, and they actually used to do that to coat statues, or gilding as they called it. And so the idea was you can get this thing as thin as possible so that this particle, this alpha particle from nuclear decay would hit the atom, and he could try to figure out where is the mass and charge, because they knew this was a positive particle. Okay, so there's 2 protons in here, and then later on we found out there's 2 neutral particles called neutrons. So let me go ahead and write down neutrons as well. Neutrons are neutral. They have no charge. And of course it was much harder to discover things that didn't have charge if you're using an instrument that deflects particles based on charge. All right, so Rutherford, so I'm going to blow it up. He thought this would happen. You know, you would hit a bunch of things about the same size and get scattering in all directions. What really happened was that this alpha particle is actually much, much smaller than the actual nucleus. So here's the size of one atom, okay? And the nucleus is right there. And so most of the time, this alpha particle would go right through and not deflect at all. So it's like shooting a bullet through tissue paper. You're not going to see any ricochet or anything like that. And so maybe there was an electron or two out here. Okay, but he knew almost all the mass was here. So, and the other thing is, he knew the mass down here was positive because they would repel, sometimes scatter straight back, when it actually did hit this very positive, very heavy center. So the model of the atom we have now is most of the mass in the nucleus, most of the mass is in the protons and neutrons. Proton has about the same mass as a neutron, a mass of about what we call 1 atomic mass unit. And so we don't, at the molecular scale, use kilograms or anything like that. And this abbreviation for the atomic mass unit is AMU. So I say approximately, not exactly. And these are about 0 AMU. They do have mass, but it's a very, very small number. Okay, so that's the model of the atom and how we kind of discovered it. One thing I do want to mention is after they discovered that the electrons are mostly on the outside and the mass and positive charge was in the middle, it still wasn't clear how the electrons were distributed in the atom. We now know that they are distributed just kind of in a cloud, more or less. Not circular orbits, but just kind of a cloud. All right, that concludes the atom.